Okay, 2-6 for Algebra 2, vertical and horizontal translations is the section. And so two things we're trying to do for this chapter, two things we're trying to learn. We're going to analyze how we're going to translate vertically, analyze vertical translations, and then we're going to analyze horizontal translations. Remember, horizontal is sideways and vertical up and down. Okay, and so we'll see a Y example in example 6, but before we get there, we're going to need two vocab words, translation, and we're going to need parent function. So we'll get to those right now. So a translation. All a translation is if we take some graph somewhere, so we've got something like this, and we move it maybe over here, right? We've translated it. In this case, we translated it down, and we translated it to the right. All right? Translation, the key on this is that same shape and size. We're not changing the shape. We're not making it any bigger or smaller. All we're doing is moving to a different position. All right? So a translation is an operation that shifts a graph horizontally, vertically, or both, but keeps the same shape and size. All right? So let's take a look at our first example of a translation. So compare the graphs of y equals the absolute value of x and y equals the absolute value of x minus 3. All right, let's do this by doing a t-table here. I'm going to make a t-table, and here's my t-table for y equals the absolute value of x. All right? So I'm going to do some positive and negative numbers. So let's see, what's the absolute value of negative 3? 3. The absolute value of negative 2 is 2. Negative 1 is 1, 0, 1, 2, and 3. So that's my t-table. And now let me do a t-table for y equals the absolute value of x minus 3. Same numbers. X is going to be negative 3 all the way to 3. So let's see what happens. The absolute value of negative 3 is 3, but then minus 3, 3 minus 3 gives me 0. The absolute value of negative 2 is 2, minus 3 gets me negative 1. The absolute value of negative 1 is 1, minus 3 is negative 2, and 0 minus 3 is negative 3. But then we're going to come back up because 1 minus 3 is negative 2, 2 minus 3 is negative 1, and 3 minus 3 is 0. So let's graph these. Here's the first one. Negative 3 and 3. Negative 2 and 2. Negative 1 and 1. 0, 0. 1, 1. 2, 2, and 3, 3. We're going to have an absolute value graph in the shape of a V here. And now I'm going to graph the set. So this was y equals the absolute value of x. And now here's, based on the t-table, let's see what happens when we do minus 3. So negative 3 comma 0 is right here. Negative 2, negative 1 is here. And I'm going to continue putting my dots on the coordinate plane. And here, try to graph better than I just did. We've got that. What happened from this point to that point? We shifted down 3. And so that number right there is going to be a vertical translation. We're going to move up or down. If it was positive, what do you think would have happened? We would have moved up by 3. All right? So see if you can do the same thing, use the same thinking, and see if you can graph y equals x plus 5 and f of x equals negative x, absolute value of x plus 2, a and b. Try those for your understanding check. All right, so now let's move on to this concept of parent function. So parent function is a family of functions. The parent function, a family of functions, is a group of functions with common characteristics. So parent function is the starting point, y equals x, right? And then we've got this family where it's always x, but we could do plus 1, or we could do 2x, right? We're just changing x around. If we put a squared on it, that would be a whole different family of functions. Y equals x squared minus 3. Y equals, I could even do this, x plus 2 squared, but the key is the squared. Okay, so each of these would be separate families, and these two would be our parent functions. All right, there are starting points on here. All right, so let's take a look at our example, and if we know our parent functions. So I'm going to start with a parent function of y equals x. I know that y equals x should have an intercept of 0, up 1 over 1. It's a 45-degree line like that. So now, what's my translation going to be? Down 2. So from my first point, I'm going to go down 2. From that point, I could go down 2 also. And here is my new line. Parallel to it because I just shifted it down. All right? In this problem, you want to be able to figure out what k is, and k is just this vertical number. So k equals -2. Anytime you see the letter k, we're talking about, for this section anyway, vertical translations. All right? For b, I know that the negative absolute value of x looks like this. Okay, we've done absolute value before. Plus 3, so k equals +3. What are we going to do? We're going to shift this thing up by 3, and then our new graph would be the exact same thing, but shifted up by 3. All right, so use that same thinking and try to do understanding check number 2. Alrighty, so now let's go the other way. They're going to tell us in words what to do. Can we write an equation? So y equals 2x. We're going to go 4 units down, so we just throw a -4 on there. It's just that simple. Y equals absolute value of 1/4 x. We're going to go half a unit up, plus half a unit. All right? Vertical translations just get tacked on to the end. I think you can do it for understanding check number 3. All right, so now we've gone up and down. Now let's go sideways. Let's go horizontally. And so horizontal translations are going to be inside with the x. All right, now, a little bit tricky on this one because we're going to end up doing the opposite of what it says. If it says plus, normally plus means going to the right, but plus means we're going to end up going to the left. And here's why. If I say this, y equals x plus 5, right? And we remember doing our intercepts. We do 0 equals x plus 5. How would I get x by itself? We would move that 5 to the other side, right? Whereas with the y, if we made the x 0, the 5 is already on the opposite side. So the y's get to stay, but the x's need to switch sides, all right? So knowing that, all right, let's identify the parent function. The parent function here is y equals the absolute value of x. Our h is -3. It's the opposite of 3, which means we're going to take this absolute value function, which normally would hit at the origin, and take it 3 units to the left. It's going to look like that. All right, if we had a negative absolute value, our parent function is the absolute value of x negative. That would be flipped over, and we're going to go, h is 2. We're going to go 2 to the right and go down from there. So with the horizontal, always go the opposite of what we see. A negative here turns into a positive for the actual shift. All right, so see if you can do some horizontal shifts for A and B on understanding check 4. All right, so let's look at writing an equation for this one. So we take a look at this blue line, and our job is to come up with the equation for it. All right, so we know with the parent function, it's y equals absolute value of x. Is this shifted up and down at all? Here's our vertex. Here's our vertex. No shifts up and down, but it is shifted over by 5. So remember, we're going to go opposite and put -5. And that'd be our equation. You need to do the same thing on problem 5, understanding check. These are both absolute value graphs. Okay, so this one's a little tricky to read on this one, I think, but it says describe a possible translation of figures A and B. So here's A, and then it's being translated. So one possible translation is we could translate it up to this triangle up here. So let's pick a point. How about this point right here? And its new point is this one here. So it's being shifted up 1, 2, 3, 4, 5. So we could say this is being shifted for A. We're being translated up by 5. How about for B? B is kind of hard to see, but it's kind of this shape here. And it's getting moved up kind of over here. So this point, I'm just going to approximate kind of this point here. For B, we're going to go left 1, 2, 3, 4, 5. We're going to go up 1, 2, 3. And those would be our translations. Can you use the same thinking to figure out the translation for figure C? And C is hard to see here, but it's basically this shape, and it ends up here, right? You might want to look in the book for a better, clearer picture for C. All right, last one here, 7. Graphing our, oh, not the last one, sorry. Closing in on the end, though. We're going to do both at once, so graph each function. Two things going on here. We're going up 1. We're going opposite of this, right 3. So I'm going to go from the origin, up 1, right 3, and from there, I'm going to do my absolute value graph. Same thing over here. I'm going to go down 4. I'm going to go left opposite 2. So 1, 2, 1, 2, 3, 4. And since this is a negative absolute value, this one points down. Okay? So see if you can put them both together here. Understanding check number 7. And now we want to go the other direction. They tell us something. We want to put it into an equation. So here was the problem. Absolute value of x, 2 units down. So I'm going to say minus 2 on the outside. 3 units left. Left is going in the positive direction. So I'm going to switch it to negative 3. If my problem here is f of x equals negative x, absolute value of x, I'm going to go 1 up, so I'll say a plus 1 on the outside. Half unit right. Oh, I'm sorry. Left is this way over here. I'm wrong on that. This would be a minus 3, so we need to make this a positive 3. I got twisted around. I apologize. Right is going this way, so we need to switch it to a negative half. We're always doing the opposite of the direction for the x's. All right, so see if you can put that together here. Come up with an equation on understanding check number 8. And that's it. Any questions, make sure you ask in class.